For this module, we're going to be doing the coding initially for data visualization, which is one of the biggest things that people are worried about is how do I visualize these plots or visualize these data in plots and where do I go from there? So this is an introduction to data visualization, including basic themes. So we're laying the groundwork for advancement in our visualizations. So this is an introduction to backgrounds, statistical themes, and text or aesthetic themes in the figures. And this information builds off of that introduction to ggplot2 that we did last week, or in the previous module at least. So as a reiteration, ggplot2, that package builds on code. So you keep code, and if you want to add a legend, axis labels, colors, or whatever, you use a plus sign. Just like we were doing with the tidyverse functions with the pipe, it's a plus sign in ggplot2. So that makes a new line of code. And it reads really nicely when you type out everything. It's the grammar of graphics. It's very much like do this to the plot, then do this, map these data, etc. So the syntax for graphing in ggplot2 is to specify your data set and variables from the data set within the ggplot function or within the geometry function. If we just have the ggplot function that includes our data and variables, nothing will be created because you need what's called a geometry or geom for the plot to be specified in the second line of code to say what type of plot you're making, a scatter plot, a bar chart, box plot, etc. So geometries can be anything here, and that's just going to be the type of plot you have. So let's load in our packages, ggplot2, dplyr, and reader. We're going to read in our fish data set we've been working with. Again, this is Fish Community Dataset from the Upper Mississippi River Restoration Program's Long-Term Resource Monitoring Element, and it's just community data from 2018 specifically of a subset of the species. Here we're going to show basic form of ggplot. So we have ggplot function. Specify your data set, specify within this AES for aesthetics function that we want to map length and weight data, and we want this to be a scatter plot of length and weight. So we have this plus sign here, and then our next line of code is our geometry, or geom underscore point open parenthesis. This is the basic default map of a scatter or a plot of a scatter plot of length and weight data from our data set, where all we had to do is specify the data variables and what kind of geometry we wanted, which was scatter plot. This is base R plotting, so it's the plot function, and you specify your data set, the dollar sign, the variable you want, the data set, the dollar sign, the second variable you want here, and it's going to give us the same thing, different defaults. I personally think it's ugly compared to ggplot, which automatically defaults to a nicer layout. But we could still make a lot of changes to make this more publication quality at this point. I want to note that for purposes of these modules or this course, and in writing most code for simple figures, it does not matter if the data are specified in the ggplot function or in the geom underscore x point line, whatever function, as long as the data frame is provided and the variables you are mapping are provided in the AES argument. The code below will provide the same figure. So when you delve into more complex figures, like sometimes you're adding data from multiple data sets, it will matter where and how you specify your data sets, whether that's in the ggplot function or the geom underscore x function. So this is something just to be aware of. It varies within this module to show that you can do both. But if you are adding multiple data sets or doing something different, then you will want to be more careful where you specify these. And by this, I mean in this line of code, we specify our data set within this ggplot function. Data set is a fish data set, and we want to do length and weight as a scatter plot. So we say aesthetics, our length and weight, plus geom underscore point is our scatter plot. This is what we just made. And we put our data and variables in this ggplot function. This function is going to do the same exact thing. ggplot here is nothing within that function. We have our plus sign. We say geom underscore point for our scatter plot, and we specify within here, within the point, the geometry, our data is the fish data set, and AES for aesthetics are length and weight. So we literally just moved this part into the geometry part. And for the purposes of just having one data set, it does the same exact figure. If you have multiple data sets, that's where nuance comes in, and that's something you can look forward to discovering out what you need to do for that, or you can ask questions as well. So the background of the figure. Right now it's white background because previously in an R file I had it set to theme few, which removes the ugly gray gridded background. And we're going to talk about changing the background color in general. So if you want the background to change for only one figure or one graph, you can use the following code in a single plot. And using this code, you can make the background any color you want, from anything like hot pink to chartreuse. Note that those are disgusting colors to have in a plot, so don't use them unless you're purposefully making an ugly plot or something. But what we'll see here is we'll notice that the grid lines are apparent if we change the color other than white, but we can use element blank to remove some of those grid lines. So here, these are what we've been working with, our length and weight data, and we're just adding on to the plot within this theme function. This theme function is a friend for many different things, all the thematics of our plot. Panel.background is going to be the actual background of our plot here. And element underscore rect means element rectangle, and that is the actual panel back there, which we can change the color of. Right now it's white, and it's a fill equals whatever color you want. So we're going to change it to red, and it makes this disgusting red color as our background, but it fills it in. We change it to anything like hot pink. Just going to change that whole rectangle. This panel grid manger are the large grid lines that are normally in R or in the background. And here we're saying it equals element blank, so just make it removed. Just remove that theme. Panel.grid.minor are these smaller lines in the background that are in the default. Again, element underscore blank makes them, removes them. So that's why there's no grid lines here, and the background is just hot pink, which is, again, not great. I would not have a hot pink background for these. But if you want to change the background for some reason, you are allowed to do that. And there's a lot of different arguments you can have other than like element blank or whatever element rect here. Just play around with some of those arguments, and you can do that by looking for the help. Theme of ggplot2. These are all the different things you can add. Line, rect, text, title, axis.title, axis ticks, axis minor ticks, axis lines, legends. All this information, you can look through every single one of these. This is way too many to talk about in a module, but so many different things you can change here. That default gray gridded background is one thing I really hate. It's just distracting and it's ugly. So I use the following function to make the background blank globally, which is why there are no gridded lines on default here. However, this code will apply to every single figures within your R section that you produce. So that's why, because I used it earlier, we don't have the default in this scenario now. If you want the gray background for some figures or the grids for others, don't run this code. But if you want to just remove the entire background, just make it blank, I would run this and it makes it a lot easier than including things like panel.background fill equals white or whatever you're putting there, removing those elements as well to remove those grid lines. And this is under the package GG themes, and it's just theme underscore set theme view, and it's going to remove that background grid lines. It's going to remove the grayness. It's just going to make it white. But this applies to your entire R session, so not just one figure. It's going to apply to all of them until you exit out of R. So one of the important things to note about figures, and at least basic figures, when you're thinking about what type of figures to make, are what's called stats. So some of the geometries that you can use within ggplot automatically create these statistics or stats needed for the figure. For example, in our fish data set, we don't have count data. We don't have sample size of each species or each habitat type, but we can still make a bar plot that actually has those sample sizes in it without first creating a sample size metric within the dplyr functions of group by summarize. So we don't need to calculate the number of observations, for example, ourselves before plotting, because using what's called the stat underscore count argument automatically does this for us. Stat count only does this if each row corresponds to one observation, though. So each row should be one individual, not like 10 to 20 or more. If you have count data where each row is a summary of the count, let's say that there's like 20 individuals within one row. Sorry, my cat is being a menace. Then you will have to do a summary beforehand to get the number of observations because it's not going to calculate it if you have multiple observations in one line. We'll see what this looks like. So if we do a bar plot of each species, we're using ggplot function, specifying our data set as fish. Our aesthetics is just the species variable. We only have one here because a bar plot with stat count only needs one because we have our species and it's automatically counting our species, so we don't have a second variable there. So we took our raw data set and we were like, okay, count by species to see the number or the sample size of individuals within each species in this data set. And we did this just with these two lines of code. We did not have to calculate anything with dplyr beforehand. We just did it here. This is a really easy way to get sample size into a figure. We can also change these stats if we want them to show data a different way as well. Like something like proportion or percent is generally a better indicator than just count. So what we could do is take something like this first row ggplot function, data set, AES species, same exact one we just did. Now we're saying geom bar for geometry bar plot. We have an AES here again. Aesthetics are our species variable where we want the proportion. The dot dot prop dot dot gets proportions, and then group one because we want the bars to represent the proportion of all fish in the data, not within like a group, subgroup there. And this gives us the proportion of species within or proportion of individuals within each species. So here, bullhead minnow is like less than 10%, 0.1 proportion. Channel catfish is the highest with a like 25.25 proportion. So this makes it more comparable. I like proportions and percents for showing data rather than raw counts. These figures are the same thing, but it's just these are comparable across study reaches or anything now at this point. So that's bar charts. You can make the stats and proportions with those. Histograms automatically count data along some sort of continuous variable rather than a factor. So these bar charts are based on factor that we have here. And histograms automatically create a bin width size for your data to be counted in. For example, like 10 millimeter size classes or 10 gram weight classes or something. Same exact code, ggplot data set, aesthetics for our variable. We're using length here instead of species. We need a continuous variable. We want to look at the length distribution of these fish. Plus geom underscore histogram, leave that open. And it creates a default histogram, our count and length of our different organisms. And we can look at the distribution of individuals in these different length bins. But what if we wanted to change these length bins? So you can change the bid width for your histograms, which can smooth or make the data more jagged. Here we're creating a bin width of 10, so each 10 millimeter size class is counted in the data. So all of this is the same for data set or fish, length variable, geom histogram, and now we're including this bin width argument. Bin width equals 10. And it makes it more jagged. You might want to change bin width for a variety of reasons based on the story you are trying to tell with your data. For these data, these fish were collected in 10 millimeter size classes, so this might be something that's important to those that funded this project, or it might not be. Depends on the story and audience you have. We could also change this to be like 100 or something, and it's going to be blockier. It's going to not have that higher resolution of data for this. So basically, all we can see is that we have a big peak around 100 millimeters or so, and then it decreases a lot. So we get the general trend, but we lose information the larger our bin widths are. And we gain a lot of information with the smaller bin widths, but that information might not be as necessary. So just think about your story and what you want to tell with these data. And then one of our other basic plots that uses statistics automatically are box plots. They automatically create quantiles and outliers of your data based on interquartile range and the 25th, 50th, and 75% quantiles of your data. So this is the same exact code, but now we need a factor variable and a continuous variable for box plots. So we say fish, aesthetics, we have our factor variable, and we have our continuous variable. Then we say plus geom box plot. So box and whisker plot, we've got our boxes, the middle line being the 50th quantile or median of our data. Lower box is 25th, upper box is 75th. Our whiskers go interquartile range times 1.5, I believe. And then any points outside of that, those whiskers are outliers and they are points on here specifically. So this is a good way to look at distributions of your data that are more statistical than like violin plots or some density plots, which are a little bit more difficult to interpret based on a statistical standpoint. But these are really helpful. One thing to note is that you can change the aesthetics and which variables are plotted for any of these. The first is always X, so we had species and then length. That's why species is on the x-axis and length is on the y. But you can switch them. You can have length as the x and species as the y. And if we plot that, it just makes the box plots sideways instead of up and down. Same exact information, just depends on how you want to show the data, if you want a long plot or a wide plot. And here we're going to get to some of the basic themes. So we looked at the different statistical methods that are inherent in some of these geometries, how to specify our data in the ggplot function and the geometry function. And we have these default characteristics that we can change the panel background and stuff with themes too. But what if we want more descriptive, like x-axis labels, y-axis labels, or anything like that? We can use some of these basic themes that are going to help us inform our reader or audience about what's happening in these figures. So we can customize the rest of the plot. The argument theme allows you to customize the appearance of many aspects of the plots, including legends and titles. Anything really, the background as well. Theme is its own function, and you add arguments to theme by using commas that separate the different functions and arguments within here. Here we're going to start with some basic text themes and add labels to the figure that are more informative. All of these themes here are included in the following code chunk, and we can go through step by step. And I encourage anyone to play around with them by deleting them, editing them, changing the arguments within here to see which each theme does. Okay, so for these basic themes, first thing we're going to do is coerce the field station variable into a factor permanently for this R session. So if we look at our fish field station variable, it's just numeric. It's just a bunch of numbers, which is fine, but when we want to do something like fill or vary it within a plot by a factor, it has to be a factor. It read it in as a number because it's 1 through 6, which makes sense for R to assume it's a number, but let's coerce it to a factor for graphing. So if we remember or did not look at the previous modules, we can coerce things by doing as.factor, our data set and variable of interest, because that variable within the data set we specify with a $sign. And we write over it. So fish $sign field station here, we're making it as a factor instead. So that'll make it a factor specifically. It still has 1 through 6, but now it's a factor rather than numeric. All right, so this is a lot more code than what we've been working with, like our 2 lines of code or so. So we're going to go through this. Our ggplot function, we're specifying our data. It's the fish. We're then specifying our variables. We're saying, okay, we want species to be on the x-axis, and that's it. No y variable here. But what we want to do is within these aesthetics, we want to fill by field station, or that f station factor variable we just made, or we just turned into a factor. And we're saying the geometry is a bar plot where our position, which we had talked about in the last module for position, equals dodge. So there's going to be side-by-side bar chart. So what this looks like initially is, okay, we have our species that we specified on the x-axis. It's automatically counting because bar charts automatically count. That stat count is inherent in a bar chart. And we have it colored in those bars, which is the fill by field station or F station. It automatically produces a legend of these different colors. Remember fill versus color here. So if we have color instead of fill, it's going to just color the outline of the bars. So if we use fill, it's going to fill it in instead. And that's the color distinction that's really helpful, is having that fill rather than color there for bar charts. So this is producing just our side-by-side bar chart, automatic legend, our original species count labels here. YLab allows us to change the y-axis label or title, and we want to change this from a lowercase count to an uppercase count. We could also name this like sample size, whatever you want it to be, we can change that too. And our xlab or x-axis label is underscore species here, so maybe we want to make it lower or title case here, species. So uppercase there. Here, we now have our axis labels changed. Y-axis is sample size, x-axis is species, which is uppercase. We can add a title, which can be very helpful for distinguishing among groups of your graphs or figures when you're initially making them, or when you have a multi-panel figure in your document. Normally, figures themselves aren't usually given titles in like manuscripts and stuff, but they can be really helpful in certain instances. So to give a title, it's just GG title, and then you write in whatever your title you want to be. We have fish collections across field stations here. So if we just run that code, we now have a title, we have our axis labels and axis titles. We notice the title is like off to the right, and usually we have those things centered, so we can change that to within the themes argument. So those axis labels and title are all outside of the themes. We've got YLab, XLab, and GG title. Now we're going into that themes argument that we had used to change that background color previously. Well, first we're going to put the axis.title.x. This specifically refers to the x-axis title, as that makes sense here. And we're saying it equals, and we want to change the text of this axis title. So that is element underscore text, and we want to make it a larger size, so we can alter the size, and we can also alter the face of it, so italic, normal, or bold text. So we're going to make it size 16 and bold. Bold must be in quotation marks here. And then a comma after our this theme is done. So that's how we change our axis title.x. And now we're going to change the axis title.y the same way. So that equals element underscore text. Size equals 16 again, and face also equals bold. So we're just increasing our size and making them boldface. Comma for our next change, our plot title. So this is the associated with the GG title here. We're again changing the text. We want it to be a bit bigger than our axis label, so let's make it size 18 instead of 16. We still want it to be boldface. And we're going to horizontally adjust it to make it centered, which is an HJust for horizontal adjustment equals 0.5, and that's going to center it. A comma for our next theme we're changing. Axis.text. Here we do not have a .x or a .y afterward because we want to change both axes texts. The text is all this, the 100, 0, 200, 300, and these species names. We would not necessarily, so like we don't have the X or Y here. If we were to make these titles the same, which they are, we can also just have the axis.title without the X or Y, and that'll go to both of them. But I wanted to show that you could do both. Same with here. If we wanted to change the x-axis text specifically and not the y, we could do .x. If we wanted to change y only but not x, we could do .y. But if you leave the .x or dot y off, it'll do it to both of them the same. So again, we're changing the text. We say element text. We're making it size equals 10. And the default is to make it like this gray color. So we're going to change the color to black just to make it a bit bolder. And since that's our last theme, we're changing no comma afterward and then just close out this parentheses that started with the theme function. So now we have bold axis titles, the species and sample size, as well as the plot title. The axis titles are larger, so is the plot title. And our axis text, so our species and sample size labels, are now black and a bit bigger than they were in that default. So these are just some of the things you can change, and you can play around with more of this. Like we could change the angle of the text. We could change colors everywhere, the different faces. We can change the legend, and we'll be building on this more in some of those future modules.